Hi everyone, I am Hariharan, Assistant Professor, Department of Science and Humanities, General Engineering Division, RMK College of Engineering and Technology. Today we'll discuss about a topic called multiplexer and demultiplexer. We call this multiplexer as a MUX and demultiplexer as a DMUX. So why we have to study this multiplexer and demultiplexer, and what are the applications of this MUX and DMUX? At the end of the session, you may understand why we are using this MUX and DMUX, right? So generally, a MUX multiplexer means many into one. So let me see this GIF I have given here. On the left hand side, you can see a switch with switch called MUX, and right hand side you can see a switch called DMUX. The switch has many inputs, multiple inputs, and it has only one output, so that is called MUX. Similarly, on the right hand side, it has only one input and it has many output, then it is called as DMUX. So let us go to the topic straight away. Welcome back. In the previous session, we discussed about multiplexer. Now let us discuss about demultiplexer. It is also called as data distributors. The term demultiplex means one into many. It is just a reverse operation of multiplexer. Demultiplexing is the process that receives the information from one channel and distributes the data over a several channel. As I told, it is the reverse operation of the multiplexer. Demultiplexer. Let me draw the block diagram of demultiplexer. Okay, a DMUX, it has one input line and 2 power n output lines. Okay, n selection lines. So this is what demultiplexer. Okay, n selection line, 2 power n output lines. Let me explain this through an example. Okay, consider the selection. Consider that we have 2 selection lines. Then our output lines will have 4. Okay, for n selection line, 2 power n output lines, the same concept like multiplexer. Their input is having multiple channels. Here output will have multiple channels. So since the selection line is 2, 2 power 2 is 4. Okay, so you can see the block diagram. It has one input lines, 4 output lines D0 to D3, and 2 selection line S0, S1. Okay. Similarly, another example we can take. Now the selection line is 3. If the selection line is 3, 2 power 3 is 8. So totally 8 output lines you have. So you can see the block diagram. It shows here 1 cross 8 demultiplexer. Why it is called 1 cross 8 means, so it has 8 output lines. Okay, so since we have 8 output lines, 3 selection lines will be there. Here the input line is fixed. Okay, this is 1 cross 8. Now let me see 1 cross 16 MUX. This 1 cross 16 MUX has 16 output lines. We can name it as D0 to D15, and 4 selection line, S0 to S3, right? Yes. Typical application of DMUX. So as like that, it has only one input, single source, selection lines, multiple destination output. So here I am going to use 1 cross 4 DMUX. So you can see 1 input X, 4 output D0, D1, D2, D3, and 2 selection line A and B. Okay, so here the input is here computer. Okay, see, you know that computer, it's a multiple processing device, right? The output of the computer you can connect to a multiple devices. like printer, black and white printer. Okay, I connected to D0, fax machine connected to D1, color inkjet printer to a D2, and pen plotter to a D3. Okay, I can connect like this. Okay, single input but multiple output. Okay, and this can be selected with the help of truth table BA. If it is 0 0, if it is 0 0, black and white laser printer will be selected. For 0 1, fax machine will be selected. For 1 0, color inkjet printer is selected. For 1 1, pen plotter will be selected. Say from the computer, you can have a Word document or any picture or whatever it is. If I want black and white printer, I can select this 0 0, so black and white print will be there. If I want color printer, I have to put it as 1 0, so color print will come. Okay, so this is a typical application of DMUX. Now types of DMUX. So DMUX type, as like MUX, we have DMUX types. So here 1 cross 2 DMUX, 1 cross 4 DMUX, 1 cross 8 DMUX, 1 cross 16, 1 cross 32, 1 cross 64. It goes on like this. Okay, we have DMUX. And this is the DMUX block diagram. So it has one input channel, 2 power n output channel, and n selection lines. Yes, let me explain now the 1 cross 2 multi, how to design or how to implement 1 cross 2 DMUX. Let me go with the logic circuit. So this is the logic circuit. See, 1 cross 2. So 2 AND gate will be there. So this is gate number 1, this is gate number 2. Okay, one selection line, yes. So this is a 2 input AND gate. So one input is connected common to the input called D, and another input connected to S through inverter like this, right? Symbolic representation, you can see it has one input and 2 output, right? Yes. Now next I will explain this with the truth table. Yes, truth table. So let us assume this S is given 0. Okay, so I am going to give S as 0. If this is 0, this will be 1 and this will be 0. Now as per AND gate truth table, if any one input is 0, the output is 0. So this will be 0. So this Y1 will be 0. Y1 will be 0. Now what about this? This is 1 and here D. Okay, so here output is also D. Yes, 1 dot D. It might be a D. The D may be 0 or 1. So your Y0 is D. Can you understand? Okay, if the selection line is 0, okay, this second gate is 0 and this gate is 1 because of the inverter gate, this becomes 1. Now totally this gate will not work. Okay, and this gate will be D. The next case, S is equal to 1. Right, now put S is equal to 1. If S is equal to 1, this will become 1 and this will become 0. Okay, so now this gate will not work and this gate will work. So this D will be here. So my output will be D. You can see it here. Y0 is 0, Y1 is D. Yes. I think now you can understand what is DMUX, right? 1 cross 2 DMUX. Right? Yes. Now let me look at the 1 cross 4 DMUX logic circuit. This is the logic circuit. This is very similar to MUX logic circuit. The difference is the output is not connected to inverter. The output is not connected to a OR gate. Okay, whereas the one more input line is connected and it is given it as X. Okay, let me explain this through truth table. Yes, I have drawn the truth table here. So two selection lines A, B. So I am going to put it as 0, 0. So if it is 0, 0, you know that the same concept I have explained in MUX also, 0, 0. So this becomes 0, this becomes part, this part is 1, this is also 0, this is 1. Now according to this combination, these three gates will not function. These three gates will not function. Only the first gate will function. Now the D0 output is depend on X. So now your D0 becomes X. The rest of the gate will be 0. So this is the first case. Second case, 0, 1. So this will become 0. This is 1. So 0, 1, 1, 0. Now for this case, first gate will not work, third gate will not work, fourth gate will not work. Okay. Now you can check the combination also. This one is connected here and this one is also connected here. Okay. So now this AND gate has 3 inputs. One out of this, 2 inputs are 1 and another one is X. So your X will be here. Okay. Now you just check it. D0 is 0, D2 is 0, D3 is 0, whereas D1 is X. Okay. Similarly, other two components also will be like this. So for 1, 0, this gate will have X, other will have 0. Okay. Now next 1, 1 case, last case 1, 1. This gate will get enabled. Other gates will be 0. So you can see D0, D1, D2 is 0, D3 is 1. Okay. I think now you might have understand 1x4 DMUX. Yeah, let us now discuss 1x8 demultiplexer logic circuit. So I have shown the logic circuit here. The logic circuit has one input D, 3 selection line S0, S1, S2 and 2 power n output lines, that is Y0 to Y7. Okay, and its truth table. Let us discuss this 1x8 DMUX through truth table. Okay, so here I have given 3 columns for selection line and 8 columns for output lines. Okay, so the first case, it is 0, 0, 0. S0, S1, S2 is 0, 0, 0. During this time, this gate number 1 will get enabled, other gates are disabled. Okay, now because of this, Y1 to Y7 is 0 and Y0 will be the output D. Okay, why it is D? Because this is based on this D. Next case 0, 0, 1. 0, 0, 1 means this gate will be enabled. Okay, second gate will be enabled. So only that gate becomes D, other gates will become 0. That is Y0, Y2 to Y7 is 0 and Y1 is D. Third case 0, 1, 0. So this Y2 gate will be enabled. So that is Y2 will become high, other gates will become 0. That is Y0, Y1, Y3 to Y7 is 0, whereas Y2 is D. And the next case is 0, 1, 1. So this Y3 gate will be enabled. So here Y0, Y1, Y2, Y4, Y5, Y6, Y7 is 0, whereas Y3 is D. And the next case is 1, 0, 0. For 1, 0, 0, Y4 gate is enabled, other gates are disabled. So Y0 to Y3 is 0, Y5 to Y7 is 0 and Y4 is D. Fifth case 1, 0, 1. Now the fifth gate will get enabled. Okay, Wi-Fi gate. other gates are 0. So you can see the table, only y5 is D. Next case 110, so y6 gate will get enabled. So here y0 to y5 and y7 are 0 and y6 will be D. The last case 111, so S0 S1 S2 becomes 1, S0 S1 S2 becomes 1. This selects last gate, y7 gate. Okay, so that is y0 to y6 is 0 and y7 becomes D. So this is the truth table of 1 cross 8 demultiplexer. You can say diagonally the output is high or low, whereas other gates are low. Okay, so with this I complete 1 cross 8 demultiplexer, right? So similarly you can try for 1 cross 16 demultiplexer with its truth table. I think you can do it as a assignment. You can check with your understanding level. Okay, and if you found any questions, you can even comments, you can give comment in the YouTube box, right? Thank you so much for your thank you so much for your patient listening. I'll see you in the next session with a new video. Thank you.